Well, welcome to this thing that we don't have. I think what I'm going to do is I'm going to change the name every single time.
Yeah.
Today I'm going to go with Kitchen Conversations. So, Ben, welcome to Kitchen Conversations. Tell us a little bit about yourself. Who are you?
I'm Ben Johnson. I work here at Fly as an engineer. And a lot of my focus has been in the past on SQLite and just trying to improve how that works and how people can run applications, web applications on SQLite. So they're just super simple.
And I think most people know me from YouTube, so I'm the Fly YouTube lady. That's me. And I wanted to chat with you today about SQLite, obviously. And I want to start by shit talking it. Not really. Y'all shouldn't
Yeah,
really
go for
listen
it.
to me, but let's start with this. So I remember from my Heroku days that one of the reasons why SQLite was not preferred, one of, was purely the nature of ephemeral apps on platforms like Heroku, where, having a single file that's constantly being updated didn't make a lot of sense for how the architecture, how most people were architecting their apps. And so, you know, you could have a managed Postgres instance, you could have that server running, but SQLite's not a server, it's a file, right? On top of that, a lot of people have pointed out that SQLite isn't really that good for large scale production apps, which I know you'll have opinions about. One of those I can think of is its lack of replication, right? As I understand, on its own, there's no like single leader replication offering that it has the way Postgres does. So, prove me wrong. Tell me how much of that is valid, how much of that has changed over the years.
Yeah, I think everything you said is totally valid. In fact, actually, the way that I actually found out about Fly originally was that I was asking online for like basically Heroku, but something that has volumes like persistent disks, because I wanted to run SQLite. I mean, if you have an ephemeral file system, especially in the past, like you write to your database and then the database just disappears, it's really not any better than writing to dev null, for example. So
Yeah.
yeah, I think that's largely true in like the Heroku sense, like the traditional ephemeral sense. And a lot of the work I've done in the past, I wrote a tool called Litestream, and that was really for backing up your SQLite database, so you kind of have a disaster recovery solution. And traditionally, that hasn't really worked on ephemeral file systems, although we are working on that and have some things coming. So yeah, I think you're right about that. And there's nothing built into SQLite that really does replication. They've done a bit of work around kind of like syncing snapshots between places recently. But Litestream, for example, just does a continuous stream of backup kind of updates or incremental backups up to S3. So you really don't have like a second service you have to run yourself. It's just like the cloud, or you can use Tigers as well, or any S3 compatible store.
Good. Got it.
Yeah.
Let's pause on Lightstream for a second. So, is it a server? Is it a second service that runs as like a proxy? I know LiteFS is a little bit of like a proxy situation, but I don't know how Lightstream works. It sounds like it's primarily for like, would you say high availability? I mean, the backups, obviously.
I'd say disaster recovery.
Disaster recovery. Cool. Yeah.
So essentially, if you can spin back up your instance and recover quickly enough, it's sort of high availability in its own sense.
Medium availability.
It's medium availability.
Yeah.
I would definitely
Yeah,
call it
exactly.
that.
Yeah, that makes total sense. And so these would not typically be stored on a volume, but rather some kind of object storage, like S3? Or could you do an up volume?
Yeah, you could do another volume. Actually, you could replicate it to that. You could do it to S3, Azure, GCS, which is Google's cloud storage, and then even like SFTP you could do. So it has a bunch of plugins.
Yeah. That makes a lot of sense. Lightstream is great for disaster recovery, obviously. There's still the question of replication for, number one, high availability, and number two, distributed apps. So there's that. Volumes takes care of the ephemeral nature of things. That's a pretty easy fix. But what about that replication aspect of things? How should one approach that, especially if you have a distributed app? Obviously, you want to keep your data close to your users as well as your server code.
Sure, yeah. So LiteFS was a project we built that kind of goes in that vein. So you can kind of think of it. People have some confusion around when to use one or the other. Lightstream is really good if you just want to have one instance of your machine running on your server, whereas LiteFS is really built for that kind of distributed system where you might have multiple potential primary nodes that could fail over in the case of some kind of issue. And then it can also replicate out to read-only replicas. And we do some kind of fancy stuff in there to try to keep track of the latest write that you went to the primary with, and read the correct one from a replica, so you don't get kind of stale data, weird, funky issues.
That's really cool. I mean, it sounds like it mimics the behavior of a typical Postgres. Well, I mean, it works differently. It works differently, definitely.
There's definitely some similarities. I mean, it's like a physical replication, and the same way that Postgres does it.
Okay.
And yeah, I would say it's a lot of the same kind of things. There's just not like a separate server you're running necessarily.
Right.
It's kind of we kind of like embed inside the file system and kind of intercept calls to be able to replicate out. Just
to reiterate, it's you effectively get that same single leader replication. One thing I want to ask about is there are some frameworks like Rails that I believe that are very intelligent about, at least for Postgres, routing read and write requests. I don't know if that's an ORM thing or I'm not sure exactly how they do it, but they take care of that. But for other apps, there's this problem of how do you, so you have a leader and you have read replicas, how do you know which requests to send where? Because your leader is going to be in one place, and usually that's okay because your app typically reads way more than it writes. There's a blog post that, was it Kurt or Tom? Somebody wrote about it, where they were saying a really easy way to direct those read writes is by using fly replay. Basically, you pretend like every single copy of your database is a write database, is a leader, even though they're not. And so when a write eventually fails, you just go up, and then you just send it over to the location of the leader. It's really that simple. Like, you let it fail, and then you just send it off. And it sounds like, wait, does that work? Is that performant? And it turns out it actually kind of is. It's actually pretty good. So I don't know if when using LiteFS, is there a common practice to directing reads and writes?
Sure. So we have kind of a built-in layer. You can run essentially like a proxy. You can kind of think of it as like we intercept calls from the file system layer to try to see where reads and writes, the transactions start and stop. So we can separate those out and replicate them out. But then there's like your application right above that, and then above that we can have this proxy layer, and that proxy basically knows who the current primary is, and it also knows, it can see essentially if a request coming in is a GET request or if it's like a post or whatnot, and we'll just redirect all posts and any kind of write request up to the primary. But it's not required, so you can actually do all this logic yourself if you want to.
Okay, yeah, because I was going to say, there is obviously convention around GET requests being reads and basically everything else being a write. To me, that seems a little shaky just because it's presumptive. I guess if you're building the app and you know that that's what you're going to adhere to no matter what, then that's fine.
Sure.
But I guess there is that one risk. So you're saying if for whatever reason somebody decides not to rely on that convention, because it is convention, right? That's something that they could handle themselves, and maybe try and do it the same way that I was just describing for Postgres.
You can fail on a read and then just redirect if you want to.
Got it.
It's certainly an option. There is some tracking around, essentially like with LiteFS, there's every new transaction gets a new ID, like an auto-incrementing ID. So you essentially don't want to read from your read replica until it's caught up to the primary, which is usually almost instantaneous, but you can get kind of little blips in there if you don't track it. So the proxy handles all that kind of behind the scenes. So if you do adhere to that convention, you kind of get that for free. But some people, they use, I know WebSockets and kind of that live updating UI sort of stuff is popular these days. So that doesn't really work with the same convention. So you kind of have to manage that on your own.
So we haven't dug into how the heck LiteFS works. And it took me a minute to understand that it was a layer between your app and your database. Is that correct? Am I?
Yep.
But it doesn't sit in front. It doesn't sit in front of your web server, does it?
No, it's a sandwich between your application and the file system.
Okay.
It's really just like a a pass-through file system, more or less. And we're kind of checking for certain calls from SQLite to know when a transaction starts and when it finishes. So we can kind of package up the changed data in there in kind of its own little package and send it off to replicas.
Can you, it sounds a little self-explanatory, but can you explain in a little more detail that pass-through file system for people who might not be familiar with that term?
Sure, yeah. So essentially a file system is just like you have your files and you open it up, you get a file descriptor, and you can do really basic calls on it. You can write to that, kind of a segment of bytes. You can do an open call on files, you can do close calls, you can do syncs, things like that. And there's just certain conventions within SQLite, like for example, where it writes to and how it writes and at what positions, that we can kind of distinguish, oh, this is where a transaction actually starts, and then where it finishes, and then any changes in between those 2 points, we can calculate essentially what data has changed and package that up, if that makes sense.
So it's this layer, when you say pass through file system,
so
it keeps
Sorry, so it's passing through to like the underlying file system that you're actually writing to. So we're not trying to like rewrite how SQLite works. We're really just trying to intercept those calls to kind of demarcate the transactions.
You know what it almost feels like? And this is a throwback to the times where to do like certain credit card receipts, if you were in a taxi, wow, I'm dating myself, where they would take your credit card and they would go on a piece
old school,
of carbon paper.
Yeah.
So you have like a copy of it. So it almost, it's not quite it, but it almost sounds like that pass through is it keeps track of the changes that need to then be replicated to everybody else before actually writing to the file system. So is there an amount of I imagine there'd be some kind of delay when it learns that, okay, we're doing a write, we're making a change to the database. So now this needs to go off and be replicated. What does that process actually look like to send off writes to all of your or replicating the database? I guess you're not. I don't know if you're technically writing or how that actually works when you're copying things over to your replicas. Because they're not like legally read replicas exactly. Technically, they're all writes, but it's just a matter of like how we're controlling the traffic, right? So when a change does happen to the leader, then what happens?
Sure, yes. A write comes into the primary, and then we can see the start and end of the transaction, in which essentially like, so SQLite's a B tree or B plus tree database, so it means there's a lot of pages that are kind of like fixed size pages of usually 4K. That are structured into like a tree structure. Mm-hmm. So we're essentially grabbing the pages that have been changed, those blocks, and then packaging it up into a file that we can then replicate out. And as soon as the transaction finishes, like kind of the instant it finishes on the primary, we have that package or that file packaged up. And then we have open connections to all the read replicas, and we'll immediately stream that out to those, and they'll pick it up, and then they'll effectively just do the same process that SQLite does of kind of the locks that applies on the database, and then writes to the database in the same way and closes it. So it almost seems like it almost just acts like another SQLite client to your database on those read replicas. But on the read replicas, we actually block writes from like local connections. So you can't overwrite your read replica on accident.
Okay, that's good to hear. You can't. Yeah. No foot guns allowed. That's great.
Yeah, well, we try to minimize the foot guns. Really.
Yeah,
there's always foot guns.
So with any kind of data replication, you always have to deal with the problem of eventual consistency. At the end of the day, you are still dealing with the speed of light and physics, and so there's always problems like that. How different do you feel like the problem of distributed data is from something like Postgres, or is it pretty similar? Like, do you have to deal with? I don't know if you would really deal with conflicting writes necessarily, but.
Yeah, SQLite is all serializable transactions in SQLite, so you don't really have like kind of intermixing of transactions like you do in Postgres. So you get around that problem. So it's a little simpler, but effectively it's really kind of the same sort of thing as Postgres. I think they have like a log sequence number that you kind of track for your read replicas, and we kind of have the same transaction ID.
Got it.
So it's all. I mean. Distributed systems are never like easy.
Never perfect. Yeah, you're always doing the best that you can. Yeah.
Yeah. So we're not solving distributed systems by any means, but we're trying to make it available for people that love SQLite.
I'm deploying an app on Fly. Let's say it's like a remix app. Normally I start my server with npm, what is it? npm run dev? What? Actually, no.
Yeah.
Why am I forgetting this? I'm so
Nailed
used
it.
to running npm run dev, and I'm like, wait, what do I
Yeah.
run in production? Node server.js. There you go.
Okay.
So that's what I normally run in production. What do I do with LiteFS? Do I need to change any of that?
Sure. So from your application standpoint, especially if you're using that LiteFS proxy, the goal we've always had is that you should minimally change your application. So it should just feel like a regular SQLite database. Use the same drivers for it, all that stuff. Obviously, the biggest change is just like having a primary and a read replica, and making sure, like if you go to change the database and you SSH into a machine, you can only change it on the primary, for example.
Yes.
So like little kind of more operational things change. But essentially, yeah, you install the Fuse driver, which is like an apt-get, install Fuse 3, and then install LiteFS. And then from that, you just start up LiteFS, and LiteFS will actually start up your app. So it kind of make sure that everything is in sync from the database standpoint before it starts your app.
Okay, so then I would assume that somewhere in our Docker file, we would need to make sure that we're installing. What were the two things you said? LiteFS and Fuse. What was it?
Just the Fuse driver. It's
The Fuse driver.
Fuse
Which
3, yeah.
okay, I just want to make sure we're clear. I don't think we defined what Fuse is.
Oh, that's a good point.
Fuse it stands for something, right?
Yeah, it's file system and user space, I think.
Something
is
like
what
that, yeah.
It's some hack of an acronym, yeah.
Yeah. Fuse file system. So that pass-through file system that you were talking about?
Yeah, it essentially lets us load up a file system without having to have like root access and all kinds of stuff like that.
Got it. Interesting.
Makes it a
yeah.
little simpler.
Okay, so that would just be something that you need to like apt-get or whatever in your Docker file.
Yeah,
Okay.
and we have Docker images of that. You can actually copy out of that Docker image, and it's pretty easy.
Yeah.
It's a one-line change.
Yeah, usually there's for those that are a little timid at messing with Docker files, there's typically on any Docker file that is generated by Fly Launch, there's typically some section where it's just like a whole bunch of apt-get this, that, and the other thing. You could just tack it onto that, I believe. It's pretty straightforward. But then it sounds like rather than having your entry point for your Docker file be your actual server command, it would be LiteFS. What exactly does that look like?
Yeah, so essentially it's LiteFS, and then you pass LiteFS the command you want it to run your application, and that just lets LiteFS connect up to all the other database instances. And if it's primary, then it can run migrations and things like that, and then it can start up your app and just make sure that everything kind of runs in the right order.
Do you know if it has to be the entry point or the what's the other one?
Or the command or CMD.
Yeah, the command, like the start command.
You can do either
whatever.
one, yeah.
Either one is fine. Okay, it doesn't matter. Okay.
Yeah, Docker does some
I know
weird stuff
those are like
around
more or
those
less
too, yeah.
interchangeable, but yeah.
So yeah, they have really interesting, surprisingly complicated rules for how those two interact with each other too.
Yeah.
So.
But anyways, long story short, your entry point, your command that needs to be run is going to be that LiteFS command. And then you pass that your actual command to start your server or start your application.
Yeah.
Okay. That makes a lot of sense. That seems pretty straightforward. What about all the complaints about SQLite that say it's not good for production? I know this is kind of BS, but I want to hear your take on it. Can you elaborate on that?
Yeah, sure, 100%. I mean, I think that there's no tool that's going to be right for everybody. Obviously, that kind of goes without saying. And I think that sure, at a certain scale, you're gonna exceed what SQLite's capacity is, and you can really scale up pretty far. Like the machines that we have available now are pretty beefy. Yeah. We run on like NVMEs and all kinds of just super fast stuff that you didn't have, 10, 20 years ago. So it's just that kind of has really changed why SQLite is like a bigger deal now. You can just do so much more with a single machine. So I think that, I think it's a great place to start, and probably depending on how big your app gets, I mean, it could probably last you a really, really long time. And if you outgrow SQLite, you're probably getting a crazy amount of traffic that you would gladly rewrite your application.
It's a good problem.
Yeah.
Yeah, it's good.
Yeah. So I think from that standpoint, you can really get going a lot faster. It can be a lot cheaper too, just to run a single machine instead of tacking on services. And a lot of people are going to add on like a Postgres, and then they might need like Redis for caching and all that. And you really just don't need that kind of caching layer if you're just running a simple SQLite database a lot of times.
Oh, I never really thought about the caching side of thing. Can you describe a little bit more about what would be necessary for Postgres in that situation? If you're using
Yeah, sure.
Postgres and you wanted to do some
Yeah,
caching.
yeah. So I mean, once you start using something like a client server model, like you're having
Hmm.
to kind of reach out for data somewhere else, and that you really kind of the latency, the query latency, even if it's like a millisecond, if you're doing a bunch of queries, that can really add up in a single request. So a lot of times people will kind of cache things and stick them in Redis or Memcache.
Mm-hmm.
Whereas if you don't have that query latency, it's in the same process literally, then you can do hundreds of queries in SQLite in a request, and it's not really a big deal. It's kind of a different mentality of how you interact with the
Amazing.
database. So it's yeah, and honestly, like at the end of the day, like how Postgres, there's not like magic code that runs Postgres. Like they run the same kind of similar kind of B tree um, database, and they might have a little more advanced data structures within there. But honestly, like SQLite is a pretty standard kind of design for a database. So you're
Yeah.
getting very similar performance from both in a lot of ways. I certainly don't want to say like SQLite is better than any other database. I think that like if you know Postgres and you just need to get a job done or whatever, you just need to build an app as fast as you can, and you already know that thing, just grab Postgres. It's great. There's nothing wrong with that. I think for a lot of people, like there's a simplicity in just running a single machine. Honestly, like for a lot of apps, it's so much simpler to wrap your head around. When you're trying to do like dev databases or if you're doing testing, it's great for testing. You can just have literally
Oh
like
yeah.
a little. They're super fast. They're crazy fast. So I think that reach for the tool that you know. If you do want to try out SQLite, I think there's cool stuff about it. Start with SQLite, maybe add on Litestream because it's really not much. It's not that complicated to add on to that.
Hmm.
And then if you do need the distributed part or the failovers, reach for LiteFS. So I think it's a good trajectory if you're looking.
Awesome. Well, SQLite is sounding more and more appealing. Thank you so much for chit-chatting with me in my kitchen.
Yeah.
Ben, this is awesome. I'm trying to come up with an outro. Yeah, I don't have really an outro,
Oh,
but
yeah.
yeah, thank you so much for chatting, and I'll chat with you on Slack,
Sounds good.
probably.
Yeah, thanks, Annie. Good chatting with you too.